Move it to the cloud. Okay. So we just reviewed mixing greens, and what else did we talk about? Ionic bonding. Oh, things that they saw. They saw trucks and mushroom. There was a cool shelf mushroom. Did you see anything cool in the last 2 weeks? Benjamin? Benjamin didn't see anything cool in the last 2 weeks.
I saw a huge leaf.
Huge leaf? What kind of leaf was it? Do you know? Do you remember the shape of it? Okay, was it? Help me remember our shape, our leaf shapes. Let's go with that.
My brother found some big leaves too.
Yes. I know of some trees dropping some big ones. Was it oval shape? No.
It was. It was kind of.
You want to draw
the
it?
dinosaur foot shape?
What?
Was it like the dinosaur foot shape where it's like?
And I'm like, are you thinking of that kind?
Yeah.
Yeah, those leaves can be big. The sycamores.
Well, those are huge sometimes.
Yeah. Okay. Was it shaped kind of like that? Kind of like that? It had kind of a heart shape to it.
Well, yeah, kind of.
Sometimes this isn't all that exaggerated, so it's just a little bit of a curve. So it could have been. There's a catawba leaf that gets really big that's that shape. We'll have to look for it again. Was it somewhere far away? Difficult to find? Do you think you could find another? Okay.
It was near my dad's shop.
Do you think you could get one and draw it in your book? Draw it in your nature journal? Thank you. Do that, and then we'll try to help you identify it next week.
My brother found one that looked like and they were really, this weird texture. It wasn't like a flat glossy leaf like the oaks, but it was more like scratchy.
Wow.
It had blotches and it was green and a bit orangish and it had jagged edges.
Oh, cool. You had two, isn't that cool? All the stuff you notice about them now that you didn't think about before. Okay, when you look, yes, I've seen some that are like, you know, like this big. Wow, cool. So you should draw, if you start to, let's say, okay, let's just say you happen to find a leaf like that and it's really big. Obviously, the page in your journal is only this big. So you're not going to draw it life size, right? You're going to have to scale it down. Yes? Draw a hand by it. That would be one way. What would be another way that you can distinguish the size? You can take your ruler, measure it from, okay, I erased it, but from that tip where the leaf starts out to the, what's the end called? The petiole to the apex. Measure that distance, and then you could draw it this big and just say, oh, from here to here is 15 feet. No, it's not going to be that big. But you know what I'm saying? So you can give mathematics a place in your journal to help you. Or you could draw something that everyone would know. You couldn't really draw an oak leaf sitting beside it and say, if an oak leaf is this big, then my leaf is this big, because oak leaves are different sizes too. So it has to be something standard that everybody knows, you know, like you could draw your iPhone 4 and say iPhone 4S. So everybody knows what size that is, right? Tiny, tiny. And then there's that, and then here's your leaf. Does that make sense? Something that you can, like you couldn't draw a Bible, because Bibles are in different sizes. Really little and really big. So something standard, or did math.
I would love to see someone like draw a note or like a Samsung Galaxy Note or like an iPhone 6 Plus or something like that, and it still be absolutely huge.
Yes, that's true. That would be a possibility. So try to use some math as you're drawing things because you're having to stare. Okay, what do you want to talk about today? You want to go back to electricity? Are you having any fun? She's
I
saying
love electricity.
she loves it, but she was a little bored last time. I cannot even remember what I assigned for you to do. Can you just read off?
Which week?
No, I'm saying in your envelope, you had some pages you were supposed to explore. And did you not pick up an envelope?
I don't think so.
Did anyone end up with an extra envelope? You didn't have one? I'll have to talk to Mrs. Hemstreet downstairs because I know she
was. I left mine here, and so she thought we had given mine to Danielle, and so she went and got it from the others. And so then we found it here, and so I had two,
and then
and now I still have two. I think.
okay, so she has two. You have none. But your brother's here, so you can work with your brother, right? And you have to get no, you don't have brother here. Sister, Bailey and Ori. Got it. Sorry. All right. This lady doesn't have any idea what she's doing. Yes.
And you showed us we made the bulb run out, but in that one it makes that two was the brightest we could do it when you did it, but there it was medium.
Oh, really?
Yeah.
Did you try it?
I didn't try to because I was afraid. I did two was like bright.
Two is bright.
Yeah, but I didn't want to make three because I was afraid it would burn it out. I didn't want to burn my bulb
Yes.
out. Yeah.
And so you're like, why? Well, that's because when you buy light bulbs, give me a second. Oh, like this. Okay, this is a good time to talk about it. Every device, let's talk about a circuit. You're making a complete circuit, right? That's what it's called, or a circle. It's going from the negative end of the battery, right? From the negative end of the battery. This is actually where the electrons come out. We always think it comes out of the positive end, but it doesn't. It actually comes out of the negative end. So the electrons are coming out and it's running through your wire. And whatever you put on this wire, it's running through those things, right? So as it goes into the light bulb, it's going in and up that little teeny tiny wire at the top. And because it's going through so fast, it heats up that little bitty wire, and that's what makes it glow. Which takes us kind of back to, remember the atoms are picking up heat, and so the electrons are looping, and they got to go back to normal, and so that it's emitting light. So it's glowing, and then it's coming down the other side and back out the bottom. Okay, it's going through the side, up the wire, across that little one, making it glow, back down, out the bottom, and back around to you. So you're making a circuit. Now, I could get that light bulb, and I could hook it up to this battery, and it's not going to light. Because that fiber, that filament that's in there, has a certain resistance, okay? That's an electrical term, resistance. It means the electrons are not wanting to pass through it very well. Okay, so it's got a higher resistance, so it's going to take more batteries to make it light. Now, I think the batteries I bought for you guys are a little low, and so that's why it was kind of dim with one. It was pretty bright with two, and three was too much. It popped the wire. So you have to match the light to the source. So that's a good thing to know. Resistance is what each one of these things has in it. And if I take one battery and I line up a light bulb and a light bulb and a light bulb, they're all three going to be super dim. because it's trying to pass through the first one, and it's trying to get to the second one. It's trying to get to the third one. It's like you're just not getting a very good flow. If you put one, it's going pretty well. Does that make sense?
Last night we watched this thing that is called How It's Made. And lots of things, and we watched how that
Oh, cool. So you can tell us.
was made. So they made a cake at first, and then they put something inside of it, maybe plastic or something, and then they filled it with this really, really toxic stuff
Mhm.
that's supposed to help. And then they put a nail on one side, and the nail is the positive side,
Mhm.
and the other side is the negative. So and they showed it working.
Interesting. I wonder what chemicals they put in it. The chemical that's in there that's causing this to start working is called the electrolyte. Okay, it's an electrolyte. In fact, that's a word you're going to hear a lot more as you get older and as you're an adult. You'll hear about electrolytes. How many of you are in sports and you've been running and sweating a lot, and your coach says, "Oh, you need what do you usually drink? Water? What? A Gatorade. Why do you think you drink a Gatorade? What's the difference in a Gatorade and a water?
The water doesn't have as many electrolytes as Gatorade.
See, you just used our word. That's exactly what I was looking for. Gatorade has some salt in it, sodium on your periodic table. Sodium chloride is an electrolyte, and potassium is an electrolyte. And trying to think of some more. I know there are others. There's about 7 or 8 electrolytes, and they're in Gatorade. Because you've been sweating, you know how if you are out a lot and you sweat, you're kind of salty. So the salt is actually coming out of your body. Your whole body is running on electricity. Okay? All of your nerve impulses are electricity. And if your electrolytes get low, they can't conduct. Yes.
So why is it that whenever we get like dehydrated or even just sometimes sick or headaches or anything, why is it that electrolytes can, help you out of that?
Because again, if your electrolytes get low, again, I'm saying your whole body is running on electricity. Your heart is running on electricity. Your brain, your immune system, anything that's moving your white blood cells over to a source of infection, all of that takes energy, and it takes electrical impulses. So if you are dehydrated, okay, there's not enough of these electrolytes to let the electric circuit pass through as fast. Now, I'm not saying if you don't drink, you're going to have a heart attack. It's not quite like that. But if your electrolytes get low, it'll make you more susceptible to things and less likely to get lost.
My mom sometimes gets headaches, and I ask her all these things like, "Have you been drinking water all day? Did you take this and take that?" And she said, whenever I had a headache, she'd drink water.
Mm-hmm.
And so I say, "Drink water,"
Yes.
and it usually makes it better.
Yes. Yeah. A lot of times headaches are generated from. Well, we could get into that based on how your cells produce energy. Requires a lot of water for every single cell in your entire body. So when you get dehydrated, your brain, it just doesn't have enough water to do the functions that it needs. Yes.
The electrolyte stuff is like reminding me of this summer I went to a summer camp called NYLT, National Youth Leadership Training. And on the second to last night, I think, I got like extremely dehydrated, and I talked to the person who had like all the first aid stuff at our campsite, and she gave me a Gatorade and this little packet that she called an electrolyte packet.
Yes.
That I had to pour in the water, and I always wondered like what exactly electrolytes were, but I never actually went and found out.
Yes. So the electrolytes just allow electrons to move faster, to move across. If I got distilled water, okay, everybody knows water. Most water conducts electricity. Does everyone know that? That's why when you're like swimming in a pool, you don't want to jump in with a radio plugged in or something like that, because it electrifies water, right? Well, truly pure water, distilled water, will not conduct electricity. It has to have something else in there that will allow the electron to jump off of one electrode. Let's call them electrodes, that's their real names, that allow it to move from one to the next, and those are electrolytes. Like I said, sodium, potassium, chlorine. I don't know why I'm pulling a blank, because there's like 7 of them that your body needs. So yeah, so say you're dehydrated, you want to keep those electrical impulses moving really fast so that your heart's beating normally and you're breathing normally and stuff like that.
My dad was saying to one of my older brothers that his phone wasn't working so well. So we asked if he could do something that he wanted out with. And that's like, don't use water. So you can use this other type of thing that won't hurt it. I must have been distilled water.
Right. Yes.
Where do you get this stuff water?
You can buy it at the store.
Is it like
That's the easiest way.
water bottles or?
Yeah, they sell them in gallon jugs or pint jugs.
Is that like the smart water stuff?
Do what?
Is that like the smart water stuff?
I'm not sure about smart water. Anything that they expect you to buy and drink probably is not distilled. Distilled has like no flavor. There's nothing in it at all. And so most people find it, you actually want a slight flavor in water. Not like raspberry, but you want it to taste like something. And so generally there's something in the water.
After I went to gymnastics, I get this horrible headache. And so even after it went away after I had a Gatorade in for like a few hours. But it took a few hours
Yes.
for it to go away.
Yep, for it to all build back up in your system. We can talk more about electrolytes and cellular respiration. Actually, I'll just save that for biology. When we get into biology, if you looked at respiration, what it takes for one cell to produce the energy it needs to just live, you'll say, man, it needs a lot of water. And your body has a lot of cells. So I think we take it for granted that our bodies are resilient, but we need to be sure to keep giving it plenty of water, especially if you're exercising. And the electrolyte drinks are even better. So let's see. That wasn't on my schedule. So I'm going to show you some fun stuff, I think. I don't know. How many of you have ever seen something that looks like this? Everybody? Does everyone have one of these in your home? Like your dad has one? What are these called?
Wire clippers?
Well, yeah, your dad's going to have a bunch of these, I bet.
I think like at least 5.
I'm sure. Very good. I was afraid somebody was going to have to go buy one. But I really want you to all have one of these. Yes.
My dad might have one of those, but can you just use regular tires? Or are they special?
This is special. And if your dad doesn't have it, you ought to buy him for Christmas. That's what I do. Because when you start to strip wires, see this is a wire that has been covered in plastic, right? So that it doesn't conduct electricity. So I can hook this up and hold this and not get shocked, which is wonderful. I got a terrible shock one time because I was trying to make an electromagnet. And so I got all of these bare copper wires and I wrapped them around this nail and I hooked it up to a battery, and it was very shocking. Very shocking. I'm like, oh yeah, that's right. I probably shouldn't touch those. So, but obviously we can't connect this to our, you can't even connect that to your, I guess if you could get it to stand up on its end, you might be able to make a connection. But it's much better if you have some bare wire at the end. So that's where these come in. Okay, this has a series of holes. How many of you have ever used these? Oh, good. Yay! You've used them, Michael? Yay! That's great. So how am I teaching how to do it? Okay, that's good. That's good. This has a series of holes, and you can actually see wires come in different sizes.
Absolutely fat one.
Yeah, they're really fat wires or they're very thin wires. You can use a pair of scissors, not your mom's really good ones, but you can use a pair of scissors and cut if you want to. But these have a really special cutting space down in the middle, so that when you put it in, you can just cut it really nice. Even when they're big, these are really sharp, and it'll just cut it straight off. But that's not what I want to do. I want to get the rubber off. So by keeping it closed, I can, see how it fits in that hole? Well, that's too loose. I move up one, that's too loose. And you can find out what gauge hole yours is. This one's about a 16. Okay, this is about a 16. So I'm going to back up one hole. I don't have my glasses on. What am I thinking? I'm going to back up one hole. Okay. I'm going to put it in here. Watch me make a mistake. And just by kind of turning it like that, you can grab it and pull. Yeah. And the rubber part came off. And my wire is now showing on the end. Okay. So this week, I gave you 3 wires, and none of them have been stripped. That's called stripping the wire. Okay. You want this stripped enough that you can connect it into your holder. Can I borrow I need your light bulb holder. Yeah, see, I didn't give you a whole lot, did I? Just battery, 2 wires. Oh, and you got a buzzer. Buzzers are fun.
I woke up my mom again.
Did you?
She's so mad.
I can imagine that. Okay. And you can take this little rubber piece off of your bulb if you want to. Should just it should just pop up. I'll let you work on that at home. And then you know how to connect things to these are called Fahrenstock clips, and you put the wire inside there.
Are we doing anything?
You're going to, but you're going to build something slightly different. Okay, so now you've got a nice connection, and it's not going to pull off. Okay, so that's what you're going to work on. Wire stripping. That's the first thing I wanted to tell you about. And if your dad didn't have a pair, save up, buy him a pair for Christmas, and a bunch of wire, because it's just, you find you can build all kinds of things.
What do we do if we don't have them?
Yes.
Okay, so if you don't have one, some pliers have like the little clippy thing that she showed you. It's more difficult, but what you can do is put the wire right there and like slowly turn it. Make sure you don't press it too hard so it doesn't break the wire, but you can get it off without it.
You
it's
can,
just a lot
yeah.
harder.
You can use scissors too. I did that earlier.
Scissors, as again, what you're watching for is not to press it too hard. With these, you can just hold it just straight up tight, and it's not going to cut it because it's the right diameter. But with regular scissors, you just want to go slightly through that plastic and then kind of spin it around without flipping.
I think I've done something like that before, where I had to cut a wire, and I think when I did it, I felt really quickly through the plastic, and then I hit something hard.
Yeah, that would be the wire on the inside. And if not, you might ask your dad, say, Dad, how do you strip the wire? I've got to strip some wires. He'll show you how to do one, and then just practice doing it. Any other questions? Okay. So you're like, okay, why are we doing that? Well, because in your handout this time, you're going to build 2 different types of sensors. This is the first sensor that you're going to make, okay? And this really isn't as difficult as it looks. Here is, okay, 1 wire. I have stripped both ends, okay? And then I put the metal against the metal of the bulb and wound it around so it holds itself tight, okay? And then the second one, I wrapped the metal around a penny. Okay, so there's metal showing here. Now look, just so you know, I stripped quite a lot. Okay, this is quite a bit to get enough so I could wrap it around the penny. Because I want to make sure that you have, there's enough, sorry, enough metal in contact with the penny, and the penny's going to come in contact with this. I put a rubber band long ways and 2 short ways. Just the 2 short ones are just holding the big long one on. If you don't put these on, this is going to have a tendency to want to flip itself off. Then you can slide this penny
On the
under
positive and negative side.
on the negative. Slide the penny on the negative, right? And then you have a tester. Because if I touch the light bulb to the positive, the light comes on, right? So then I could put something in between, okay? Let's say like a piece of paper. What do you think? Do you think the light will come on? Okay, why doesn't it come on? Okay, so electrons don't want to flow through paper, okay? Now, I'm afraid that if the paper were thin enough, like a tissue paper or something, it might make its way through. There may be enough spaces, but this is thick enough that this is called an insulator. If it doesn't let the electrons through, it's an insulator. If it is, let's see, what is something else I could explore? What about a paper clip? You think? Okay, so see, then I can actually stick my paper clip on there and I don't have to hold it with my fingers. I just don't like putting my fingers in the circuit somehow. You know, if you can keep your fingers out of the circuit, it's much better. But then you can touch the paper clip because this battery, yeah, it's a bigger bulb and my battery's in this big. Okay, so you see, this is called a conductor. If electricity flows through, it's a conductor.
The metal.
Yes, exactly. So most of you can go, oh, okay, I'm going to fix some metals. Yes.
Whenever I'm trying to get something out of a toaster, my dad doesn't like me to use a knife because it is metal or it's like sitting anywhere.
Yes.
So he said use wood because wood doesn't conduct electricity.
There you go. So you guys already know all this stuff. Am I just boring you to death? Well, I'm glad you know it. So now your push is to learn something new you haven't done. Well, actually, stripping wire, you've never done that before. So that's something new. Okay. So this is your first tester. And on the first page, it's gonna, I want you to find 5 things that are insulators and list them on the page. I think it gives you 8, 8 slots. Just find 5. 5 insulators, 5 conductors using this setup. Okay? And then you're going to do a second type of tester. You're going to set up another kind of tester. And it's on this piece of paper. Okay? So I'm just giving you this piece of paper. You're going to have to look at it, figure out how to set this up. Okay? But it's really pretty easy. I'm going to show you how to do it now. Just so you've seen it. Does everybody want to see it at least once? Okay, well, with the exception that my penny just fell out of here. I'll try to fix that. And it has you doing, let's see. I'm going to take my bulb out of here. Taking my bulb out. There's my penny again. My goodness, I am in trouble.
Which there's like tape it on or something.
Yeah, you can if you can use masking tape. Nope, you can use masking tape. Okay, now this one, Scotch tape doesn't tend to want to stick.
Yeah, I used it. Actually, I kept sticking.
Really? Well, anything
When
you
you
can
do
get
it,
that
come on.
works. Okay, this is a super long one. In the picture, you're going to see they do a short one. So in your handout this time, I gave you 2 longs and 1 short to be added to your set that you already have. Did you hand me your set? Yeah, here's her set. Okay. And here is her. We're going to have this test stream like 500 miles long. Well, let's make a short one. What do you think? Let's make a short one. See if I can. Do you have a short wire in here?
You can just take out the wire, probably from.
Watch this. I'm gonna make her just have a heart attack. So now you got 2 short ones. Actually, you'll have 3 short ones. I'll give you another long one too. So you have plenty. Ah, long hole. I bet Austin's. I bet you're an expert at this, aren't you? Does your dad let you do this much?
Yeah. I haven't been on a job with him in a while, but I think that the last one that we did was, or that I did with him was actually one of the only wiring a new construction home he has done in years.
Oh, wow.
That was pretty
Nice.
fun.
I bet it was.
Yeah, I got to go up into the rafters and climb around.
Cool. The old wire that you had, you'll notice a difference. The old wire I gave you last week, have you noticed that there's lots of little ones? The core is a bunch of little ones. I went with solid this next time, so it's just one piece instead of all these little things. Because when you try to thread it through these things, they just come all undone.
Yeah.
So, yeah. Okay, so is this going to work? That's the question. And I'm behind the camera, so they can't even see.
I've got a question about the wires. One is red and one is pink. Are they different?
No, they're just colored so that you can keep track, especially when you're wiring a house. You have to make sure that the positives keep going positive to the positives if you're doing series, parallels. So if you put all your reds positive, all your greens are negative, now you can just look at it and know which ones are which. And when you get into electronics, my brother works in electronics, and they'll have like 10 or 12 different colors because each color is a different system that's wired, and it worked fine until he realized he was colorblind. He has a hard time telling the difference between green and blue, so he would make some mistakes when wiring it. But once he knew about it, then he always had somebody check it. That looks blue to me. That's green. So now basically what you have, I'm sorry, I'm taking up our time, me doing stuff like this, but I'm going to show you why you might want to make a box too in just a second.
There's the box on the bigger.
Yeah.
I found some small batteries that were the same voltage as the big one. So I could use the small batteries and not have to take up the
Oh, that's cool. That's really good. Let's see if I can get this on your negative side. What happened to my positive? Okay. All right. So now, obviously, I'm thinking, what did I do? Wrong. Wrong. This is supposed to go here.
Why are you using a pin?
It just makes it a little bit more stable.
Copper.
And it conducts electricity. All right, so here's my battery. There's my light bulb, right? And then this one
You're taking these wires really long.
I know. I gave you long wires, but then you'll have your cutters. You can cut them any length you want them, okay? But I figure I'd rather give you more, and then you cut them back than me giving you short. I was like, why are they so short? Okay, so according to this, now you've got a new kind of tester, right? I can touch them together, right? And it should light, okay? Because I'm not shorting it, correct? I'm just completing the circuit. So that tells you now, when you make your quiz board, which I'm going to show you next, you're going to need 2 ends, and you're going to attach one to one place and one to the other place. And if the light comes on, then it's correct. And if the light doesn't come on, then it's not correct. If that makes sense. This is your second type of tester. Now,
The other type is easier to use.
well, it just doesn't always work because the other one, we have taken it apart now, because you have to have one item between the battery and the light. In this, I've got 2 points, and I can touch 2 different points and see if there's a connection between them, which is where the you guys have seen these all over the place. This is how I set up the basic one. Okay, it's a quiz board. You're gonna make questions. I set mine up with 1, 2, 3, 4, 5, 6 on each side. Okay, 6 on each side. 6. So maybe over here we would say something like, oh, you can't read that. I need a pen. All right. Let's find a pen. So maybe on this side, I will say 1 plus 1. Okay? And I have to figure out which one over here I want to be the correct answer. Where do you want the correct answer to be?
Second to bottom.
Second to the bottom. He wants it to be here. So over here, I'm going to write the number 2, right? And then you're going to take, these are brads. Okay, brads are made out of, what are they made of? All I know is that they conduct.
Is that the brand name?
No, they're called round head fasteners. That's the name that's on them. You're going to put a brad in this side, okay, and a brad here. And guess what you're going to put from here to here?
A wire.
You're going to put a wire. And then when you touch with your tester, okay, I'm going to try to hold it like this. When I touch with my wire, 1 plus 1 equals 2, the light should come on. Does that make sense? You guys see that? No, because I'm not connected. I'm having a hard time keeping my battery connected to my wire, right? And then of course you can flip these down. After you get your wire hooked up to it, you can put a piece of tape over it so nothing else can touch it. Now, you've seen these before. How many of you have gone to the Science Center and maybe they've had a big board up somewhere and they have a question and you have to push a button, or you have to hold a question and hold a button to get a light to come on or something like that? I've seen them at Science Centers or at nature trails. They might have something like that where you touch this button and touch that one and a light comes on. This is all that is. Okay. She's looking. Yes.
If like, does it just always come on if you have like, you put a wire over both and then touch one end and the light comes on. If you touch one end to a different end, like you got 3 plus 3,
Yes.
6, and you push 1 plus 1 to 6, would it not light up?
No. Can you tell me why it wouldn't? Okay. Let's do that.
First, the circuit is complete. You have that wire.
Let's go ahead and. No, I shouldn't. Let's use one of these, and we're going to connect it. What time is it? 12:42. What time do we get done? Okay. Oh, we should cut it. That's what we should do. I should have had one of these ready to go, but I thought you'd like to see how it's going to go. Now, obviously, you're not going to do it like this. Right? You don't want a big loopy piece of wire. Just cut long enough for it to just be straight like that. Tape down both ends, okay? But now, see, I've got to have a conductor. I mean, I've got to have one more piece of wire. One of yours.
That's my brother and take a video to ask him. He's like, okay, you have to push this one to whichever question you think.
Oh, look. This one's a little short one. Maybe I should have done this. Actually. Okay, now what can I do? Cut a new piece of wire? Strip somebody else's wire for them? So they don't have to do it this way? I don't know. I want you to do it. Let's see if I can find more wire.
You could just attach two little ones together.
Well, I want to get the, that one's a little bit too small.
Where'd you find that? Where'd you buy that wire?
Radio Shack, but you could get it at Lowe's or any kind of place that has electrical stuff.
Call 1-800-988-8731.
I'm almost done. And then let's go into, where's my paper? Let me see what else I can say while I'm working on this. Oh, drawing. Drawing the schematic. We got to talk about drawing. Did you guys use that key and you were able to draw the things that you put together? Like she's got drawings here of a
That was my
battery.
dad.
You're dead? Okay, now let's see if we can get this to stay. Now, obviously, you guys know that this is not the optimal way for this to work, right? Uh-oh. Poor Conrad won't get to see it. Or whoever's watching this. This is why we want a box, just so you know, so you don't end up like having to just sit here and make sure you're not touching anything wrong so it all falls apart. You want it to kind of hold together, right? Okay, so now here's our board, right? So if I touch the 1 plus 1, not quite underneath, 1 plus 1, and 2, I'll hold that down. You touch the 2 and I'll touch the 1. Yay! So the light comes on. Because it's coming from the battery through the light to following the wire across the back to here. So that's what's completing your circuit. So then that makes sense why if I touch here, there's nothing connecting 6 to this. So it won't do anything.
Cool. Could you put answer on one side, only one, and then put a question on one side, and then just a bunch of answers if you just wanted to.
Yes. You could, so she was saying you could put one question and then multiple answers. Okay. The most efficient use of something like this is to have a one-to-one correspondence so that each one of these is wired to one of these other ones. So you'd have a total of 6 questions you could ask.
Are they going to be math? Or
No, your questions could be anything. I was just trying to think of something simple. You know, you could say,
what's my dog's name?
I guess you could say that, or you could say atoms are made up of protons, electrons, and then somewhere over here have neutrons. It could be, you can test anything that you want to test or something you want people to review. So I want each of you to make one of these. This is just a piece of cardboard that I cut off of a box, right? And I put a plain piece of paper over the top because it's just easier to read. Once you wire this, okay, like I said, you want to use kind of the shortest wire possible. So try to cut that, okay, and take these ends down. But then you still want to kind of cover up the back because somebody could just go, oh, I got it. And they don't read the question. They just look at your wiring on the back. So you don't want them to see the wiring.
Could you like put another piece of cardboard over it?
Yes. Yeah, or just another piece of paper or be creative on that. Now, the next thing I'm saying is, as far as this goes, this is where the little box comes in. And here was my idea. I had this little box because I bought a new piece to my mandolin that just works perfectly. I absolutely love it. But it came in this little tiny box. And I went, oh, you know what? That is like the exact size of a D battery. Okay? So you could have this come out the top. You could mount, I mean, you wouldn't have to have this much wire, right?
You can put it in a little.
You could mount this on the top like this. And now you're carrying this around.
It's a lot easier.
Much easier. So I thought, wow, I should show you this little box. And then I thought, you know what? This box just pops together. Let me show you. This is all just one piece.
How is the paper box, for instance? Don't you think you have to use cardstock or something?
Well, yeah, you need to get a piece of cardboard.
Yeah, you don't need to bring the paper design.
Oh, yeah, no, this is your pattern.
Yeah.
So then you're going to print this off and lay it on a piece of cardboard and cut out of cardboard. I want to show you how it goes together because I'm going to have my daughter help me with the directions. See, it's just all one big piece. So that's what this is. But then I started looking at it going, oh, how will they know how to fold it? I'm going to come up with, just realize this and this, these pieces are cut, right? The center section you want to be able to fold the center section up, right? These two pieces fold up.
It doesn't look the same as the box. There's like an extra.
It's not. Because I just put this on the printer and printed. Okay? I will come up with a way of try to mark where to fold it, but I thought you'd want to at least see it go together, okay? So you're folding up these two sides, and you come into the center. You can see it's already starting to take shape, right? The bottom piece folds up. Right here.
Yeah, and then push that in.
Yeah. These two go in. Is that right? Give me a minute. Okay, keep these up. Okay, let's try that. Fold the bottom piece up and fold it in, but keep the top open. And then the bottom piece up and in, right? Then these fold in. And then this one fits in perfectly. It's a perfect little box. So it might be worth printing that off just so I will get it onto Jupiter Grades or try to get you a copy of that. So you can make a box if you want to, or you can buy a little box. You're all going to need some brads. Somebody help me put 6 brads in each of these. No, it needs to be 12, right?
Yeah.
That's not,
pick up all of them.
it is, because there's only 100 in there. How about if I give you 10 each? No, that's still 130. How about the 8 each? 8 times 13. It's still 104.
6.
Does anyone have these things at home?
I think we have some.
I know what they are, but I don't have any.
Okay.
I might.
Okay. Let me give you 6 each. Okay, we'll give you 6 each, and then scavenge hunt around your house. See if you have them. Okay, I got those at Staples. It's 100 for $3, so they're not expensive.
Could you just use nails?
Well, the beauty of these is that on the back you can fold them flat.
Yeah,
A nail is just gonna
Pound
be,
the nails over like that.
I guess you could, or you could probably do it with a paper clip. You could, yeah, you could do something like, you could probably fit a paper clip into the hole. I'm gonna hurt myself. I can see it.
Like unfold it, push part of it down. Pull it back.
Yeah, so you could probably do something like that with a paper clip. Okay, so paper clips will work. It's just not as, this is real easy to see, and I think I like that a little bit better. So you're going to build a quiz board with, did I tell you how many? What did I say on your assignment? How many questions?
You're giving us 3 questions, but I don't know.
Yeah, I'd like 4 questions. So 4 questions, 4 answers, but you're going to have to
Oh,
find.
it's 5 questions.
That's it. I think 5. Well,
Yeah. we can-
you think you guys can handle 5? You might have to use paper clips.
These 5 questions.
5
on that
questions.
scoreboard.
Yeah. You're going to build a scoreboard. This one has 6 questions. So you'll have 1, 2, 3, 4, 5 questions. Of course, 5 answers.
I could do 6.
If you want to do 6,
We
Go
need
for it.
5. We could do 10.
okay. So then let me put your kit back together. Or, if you would rather wire your buzzer instead of the light so that it buzzes when you get the right answer, that's fine too. Okay, so the only thing you'll have to do here is you may have to strip a little more of that because that's a very tiny piece.
And then
You're going to have to attach your piece of wire to this, and now you've got an exposed wire. How many of you have ever used electrical tape? Okay, there's a secret to electric tape. It's not super sticky like this. Okay, it's a little bit sticky. The stickiness comes in when you pull it, right? So as you connect these 2 pieces, okay, you're going to kind of twist them together and then start this. Then you're going to pull it as you twist around it.
what if you don't have
I bet your dad has it. I'm pretty sure your dads have this stuff in their house. In your house?
Can we get it at like Hobby Lobby or something?
Yes.
Like that?
Yeah. All right.
We have
So you can do. Yeah, but not enough to give. How many are there? Because there's 13 packets.
13 people.
I don't have those. Oh, that was my own one. I'll show you. This is another thing that can be connected to a circuit. This is called a telegraph.
21.
Really? So give everybody one more. If you connected this and this to an electric circuit, then when you touch it, it would make whatever happen. So most of the time it's a beep or a beeping sound. So this is Morse code. That's how that works. Okay, so it's just like a switch in an electric circuit. Thought you'd like that. So everyone grab one of these. You're going to need one each of these papers.
You need one of these.
Okay, fine.
Yes.
Here, I think this one has 7.
Okay, we're gonna put it over here. Here, okay.
Oh, you know what? There's 3 more. Is that gonna help us? No?
Yeah, we had 21. So that would make 24.
Yeah, we need
Just 2 more.
I know, well,
We have 8.
I bet we have extra
mhm,
somewhere.
there's,
Yeah, and I don't mind not getting an extra one. My dad probably has tons of them.
I bet so. I bet so. Here's like,
Either he has them or Tony does. Tony is one of the employees and he does low voltage. So
oh, yes. Okay, I think this is my extra wire. Extra wire. And so I've got to figure out how to set you up.